Okay, folks, I got a little video for the other three questions for you. So just remember, when taking integrals, you're either going to be looking for the derivative of the outside sitting there, or you have to, it's either going to be an ln problem, or you're going to have to change the format of how it looks. For example, if I tried to integrate this one, I'd need the integral of 1 over 2x sitting outside, and I don't see anything like that. First of all, I don't like the way this is written. I'm going to get rid of fractions whenever possible. I'm going to write this as... So unfortunately, even in this format, there's nothing much I can do. They never do this with any more than a second power, but I have to expand this thing out by foiling it. It's the only way to solve one that's like this, where you can't counteract the derivative on the outside because it's in two parts. So we have to square it, and this is what we get when we square it. Okay, so when we foil this, I'm going to write it out twice just so I can see it. This one is a really hard one, harder than the normal ones that are there. X minus 1/2 x to the negative 1, x minus 1/2 x to the negative 1. So when I FOIL its first terms, give me x squared. The outer term is x, it's negative 1/2 x to the negative 1 times x to the 1. Well, what happens to these two things is they cancel each other out, and the outer becomes 1/2, negative 1/2. The inner also becomes negative 1/2. They combine into positive 1. And the last, when we multiply those, end up being positive 1/4 x to the negative 1 times negative 1, which is to the negative 2 power dx. So when I integrate those, I end up with 1/3 x to the third minus x, and now I'm going to deal with this one. I'm going to go up, x goes up to the negative first power, so negative 1 comes out with the 1/4, negative 1/4 x to the negative first plus c. I'll look through my problems. The correct choice that matches it is C. Okay, for the next one, once again, if I don't have to have radical, if I don't have to have things on the bottom, I'm going to get rid of them. I'm going to rewrite this as the integral of 2y minus 3y squared to the negative 1/2, because I brought it up, times 1 minus 3y dy. My only hope is that the derivative of the inside has something to do with that piece that's lying over there. So I'm going to take the derivative of the inside, and I get 2 minus 6y. Well, that's not exactly what I have there, but it's pretty darn close. If I took this and I multiplied it by 2, I would have the derivative of the inside sitting there, and I put a 1/2 on the outside. So the integral of something to the negative 1/2, I can go, is going to go to the 1/2 power. 2y minus 3y squared times 2 on the outside times that 1/2. Those are going to cancel each other out, and I'm going to end up with radical 2y minus 3y squared plus c. So it's going to be choice E. So then the last one we're going to look at, which is number 13. Okay, I'm taking a look at number 13. It's going to look like, to me, it's the same type of thing. What's the derivative of the inside of that fraction on the bottom? It's going to be something x. So what I'm going to do is I'm going to get rid of fractions whenever I can. I'm going to make this the integral of 1 plus 4x squared to the negative 1/2 times x dx. The derivative of 1 plus 4x squared is 8x. So that means I need to put an 8 here. Counteract it with a 1/8. I'm done with that. Integral something to the negative 1/2. If you haven't learned yet, they love powers to the 1/2. It's going to go to the 1/2 power with 2 over 1 on the outside, and my 1/8 is still there. So it's going to be 1/4. 1 plus 4x squared to the 1/2. I'm going to look at the answers. This was number 13, 1/4. I have to look at it carefully. I don't necessarily see it. Oh, there's one thing with a 1/4 on the bottom. So that would have to look like that, plus C. So the correct answer is B. There's a little more help. Don't worry if you don't get those ones yet. We're going to go over those fully on Tuesday. Monday's going to be derivatives. Tuesday's going to be integrals. Take care.